Hello and welcome to lesson 6.2. Today we're going to look at slope-intercept form. Before we do that, we need to look at a few things first, okay? One of those being a linear function. A linear function is nothing more than a function that graphs a straight line, okay? There's no curves in it whatsoever. It will literally be a straight line. It could be an angle that has a positive slope, a negative slope. It could have a zero slope or be a horizontal line. Okay, as long as the graph is a straight line, this is a linear function. Now, when you're looking at the function itself to determine if it's a linear function or not, or a linear equation, okay, you can tell right away because your variables cannot be raised to a power. So if your equation has anything like an x squared, an x cubed, an x to the negative first, like a 1 over x squared, any of these are not linear functions. A linear function could be something like 2x minus 1, just x, 3x plus 5, negative 2x plus 10, and so on. There's many, many different variations. But if you notice, the key thing with all of these is that the variable is just x, and there is no exponent on any of these. Now, when we're looking at the equation of a linear function, the equation itself is actually pretty important because it gives us more information than what we realize. Okay, so if we look at this equation, y equals a negative 2x plus 1, if you wanted to, you could create a table kind of like what is done here, and they just picked a few x values. Okay, we have 0, 1, and 2. And when you plug 0, 1, and 2 in, you get 1, negative 1, and negative 3. Okay, so we have our domains here and our ranges here. Then if you go and you plot those points, you can see that you have 0, 1, then you have 1, negative 1 right here, and we have 2, negative 3 right here. And we could have done more points in either direction. So with this, we can find the slope, which if you recall from 6.1, this is actually like the amount that our line is either increasing or decreasing. And slope, remember, is represented with the lowercase m, and that's equal to y2 minus y1 over x2 minus x1. And we can find what we call the y-intercept. So the y-intercept is right here, and this is the y-coordinate where the graph crosses the y-axis. So right here on our graph, if you can see, maybe I'll change the color. So right here is our y-intercept. Now, with our y-intercept, something that you should know, okay, at the y-intercept, this is where our x value equals 0. So like if I look at my graph up here, my y-intercept, I have the coordinate point 0, 1. Now this point is important because if we know the slope and our y-intercept, we can write the equation of a linear function. And we can do this because we have this form called slope-intercept form. This formula, as I've mentioned to you, is very, very important. Okay, this is something that you're going to use a lot in your math career, so please start to memorize it and please understand where the pieces come from. Okay, so the key pieces in this formula are the actual slope. Okay, now the slope is going to be the m, or the number in front of the variable. Then the b, or whatever you're adding or subtracting to the mx part, this is going to be your y-intercept. So if you know these two numbers, you can plot any straight or linear line. So looking at example 1 here, let's see if we can identify the parts of this. Here's an equation in the form of y equals mx plus b. Part A says what are the slope and the y-intercept of the function y equals 2x minus 3. So if I look at my slope, my m is going to equal the number in front of the variable, or in this case, it's going to be 2. So this tells me my slope is going to be positive, or when I go to graph it, my graph is going to increase as I go from left to right. My y-intercept, okay, which is really my b value, is going to be this part right here, or a negative 3. So if I go and I graph this, or if I look at a graph, my y-intercept is going to be down here at the coordinate point 0, -3. Likewise, for part B, it says, what's the slope in the y-intercept of y equals -6x plus 1? So here, my slope is a -6 because that's what's in front of the x. And my y-intercept, or my b value, in this case is just going to be a +1. Now for example 2, we're actually given the graph, and we are going to write an equation that is modeled in this graph. So right away, I know that I can find my b value. My b is my y-intercept, and that's going to be this right here. So notice my coordinate point is 0, 1, and this one right here is going to be the b value. So in my equation, y equals mx plus b, based on just looking at my graph, I now know that I have y equals mx plus 1. So now we just need to go ahead and solve for our slope, or m value. In this case, if I use the 2 points that they give me, 0, 1, and 3, -1, I have x1, y1, and x2, y2. So if I calculate my slope, remember slope is y2 minus y1 over x2 minus x1. So here I really have a -1 minus 1 divided by x2, which is 3, minus x1, which is 0. So this gives me a slope of -2 divided by 3. Now I know that the negative is correct because notice my graph is decreasing as we go from left to right. So that's correct. Now the other thing I can do is if I pick 2 points, kind of like what's given, and let me just erase some of this here. Another way you can verify your slope is if I look at this point and this point right here, notice I'm going down 2, so here's 1, 2, and I'm going over 1, 2, 3. So this -2 tells me that I'm going down 2 units, and the 3 tells me I'm going to the right 3 units. So that means that my slope is correct because I was able to verify it by going down 2 and to the right 3. So now to finish writing my equation, since I know what my slope is, I can say y equals a -2/3, which is my m, x, and then I have that plus 1 because that's my y-intercept, and this is the equation for that line. So for example 3, I'm told to graph these. Well, the nice thing with this is I know my y-intercept in the equation y equals 3x minus 1. So I'm going to go on my y-axis. Remember, this is my y, this is my x. So if I go down to -1 and drop a point, then my slope is really 3, or it's 3 over 1. So because I have a positive slope, this tells me I'm going to go up 3 units, and then I'm going to go to the right 1 unit. So if I go up 3, that gives me 1, 2, 3, and I go over to the right 1. Then I can go up 3, so 1, 2, 3, and over to the right 1. And then what I'm going to do is I'm going to go ahead and connect these points. Okay, so if I connect these points, I'm going to end up with something that looks like this. So graph A, and I'll label that A, will be the blue line. Now for graph B, I'm going to use a red color. Notice my y-intercept is -2, so I'm going to drop a point at -2, and my slope is equal to a positive 1/3. So this means I go up 1 unit, and I'm going to go to the right 3 units. Okay, so I'm going to go up 1 unit and to the right 3. So 1, 2, 3. Up 1, over 1, 2, 3. And then I'm just going to go ahead and connect those points with a straight line, and I end up with something that looks like this. And again, that was graph B. Now for graph C, my y-intercept is a positive 2, or right there, and my slope is really equal to a -1. Now this is really a negative 1 over 1. Now me personally, I use my negative sign to tell me that I'm going to go down 1 unit. And then I always take the bottom and that I'm always going to move that to the right. So I'm going to move to the right 1 unit. So if I start out at 2, I'm going to go down 1, and I'm going to go over 1 to the right. Down 1, over 1 to the right. So now what I've got is I've got a graph then that's going to look something like this. And this here is graph C. For example 4, we're going to write an equation in slope-intercept form given the points 3, 5, and 5, 9. So the first thing I'm going to do is I'm going to go ahead and calculate my slope. So I have m equals, and I'll call this x1, y1, this x2, y2. So I have y2, and remember, m equals y2 minus y1 over x2 minus x1. So this gives me 9 minus 5 divided by 5 minus 3, or I end up with 4 divided by 2, which in fact is 2. So now I have an equation that says y equals 2x plus b. Now in order to find the b value, what I have to do is I'm going to take one of my points that has been given, and it does not matter which point. Okay, so I'm just going to take the point 3, 5. And remember, 3 is an x value, 5 is a y value. So now in order to solve for b, I have to plug in my x and y values. So in this case, I have y is equal to 5 equals 2 times my x value, which is 3, plus b. So I really end up with 5 equals 6 plus b. And if I get b by itself, or I solve for b, I have to subtract 6 from both sides, and I get that b is equal to a negative 1. So once I know this, I plug it in up here, and I end up with the equation y equals 2x minus 1. And that's the equation that will go through both of these 2 points. So let's do this again for part B. So I'm going to label my point x1, y1, x2, y2. Calculate your slope. So I have negative 1 minus a negative 13 divided by 2 minus 5. Well, when I simplify this, negative 1 minus a negative becomes plus. So negative 1 plus 13 is 12. 2 minus 5 is really a negative 3. So I end up with a slope of negative 4. So I really have y equals negative 4x plus b. Now I need to substitute. And again, it doesn't matter. I'm going to pick this point this time only because my numbers are smaller. So my y value is negative 1. Then I have negative 4 times my x, which is 2, and I add that to b. So really I have negative 1 equals negative 8 plus b. I need to get b by itself, so I add 8 to both sides, and I can see that b then is going to equal 7. So now what that tells me then is my equation is y equals a negative 4x plus 7, and this is my final equation. So our final example today says the base pay for a used car salesman is $300 per week. The salesperson also earns a 15% commission. The equation T equals 300 plus 0.15S relates the total earnings, which is T, to the sales, S. We have to graph this equation. Now the thing about graphing story problems is sometimes you have to stop and think about what makes sense, okay? So in this problem here, I know that S is going to represent my sales. Well, a salesman is not going to take a negative sales, okay, because he's getting paid commission on what he sells. So if he doesn't sell anything, it's 0. So when I set this graph up, I'm not going to create a graph that has a negative X or Y. So I'm going to set up my graph first. So I have my sales on my x-axis, my earnings on my y-axis. I'm probably also going to set up a table just so I have, just so that I can see what I'm going to have to plug into my graph here. So if I call these my S values and these are my T values, I know that if we sell $0, that this salesman is going to make $300 still. Then if he sells $100, he's going to make $315, and I'm getting this all by plugging it into this equation. So if he sells $200 in sales, he's going to make $330. If he does $300 in sales, he's going to make $345, and we'll stop at $400. So if he sells $400, then he's going to make $360 in sales. Now, what you need to do is you need to set your graph up so that it's not super tiny and everything looks neat. So I'm going to go ahead and space my units out along the bottom and along the side. So I'm going to make each tick mark along the bottom be $25 in sales. Okay, and if I make each tick mark along the y-axis 25, that will at least cover all of the numbers that I have in my table. So now I'm going to go ahead and plot my points. So I have the point 0, 300, which is going to start out right here. Then I have the point 100, 315. So that's going to be just a little over 300, but not quite to 325. Then I have 200, 330. So that's going to be just above the 325 mark. Then I have 300 is 345. So that should be just shy of the 350 mark. And then 400 is going to be just shy of the 375. So if we go and we draw a line through these points, you should get something that looks like this. Please let me know if you have any questions. Otherwise, I will see you guys in class.